Hello students, and today in the next part of the aerosol we are going to understand about the actuator. They are the specially designed button which help in delivering the drug in the desired form, that is spray, wet stream or foam or solid stream. Means when we the product expel out from the aerosol, it can be in the spray form. Spray means but we are using the spray, normal spray like that. Wet stream or foam, it can be in the form of foam or solid streams like a semi-solid coming out from the aerosol. So in what form this product is going to come out, that depends on the type of actuator. So based on that we have various types of actuator: spray actuator, foam actuator, solid stream actuator and special actuator. Spray actuator, it can be used for topical preparations such as antiseptic, local anesthetic spray or bandage, etc. It allows the stream of product, concentrate and propellant to pass through the various openings and dispense as a spray. The foam actuator, it consists of the large orifice compared to the spray, which range from 0.70 to 0.125 each. Solid stream actuator. This actuator are required for dispensing semi-solid products such as ointments. Special actuators, they are used for specific purpose. It delivers medicament to the appropriate site of action such as throat, nose, dental and eyes, etc. Here are the example or the figure of the various actuator like a spray actuator, different types of actuators and foam actuators. Meter dose inhaler, used to minimize the number of administration error. Means when we deliver the drug via the aerosol, there are various errors we are going to face. So with the use of meter dose, we can minimize the administration error. To improve the drug delivery of aerosolized particles into the nasal passage and respiratory tract. Advantage of meter dose inhaler, it delivers a specific amount of drug or specific amount of dose. That is specifically used for the potent drugs. It's very useful for the potent drug where the minor change in the dose is going to change the therapeutic that efficiency to the toxic effect. Portable and compact. Quick to use, no contamination of product. Dose reproducibility is high. Disadvantage of meter-dose inhaler are low lung deposition, high pharyngeal deposition and coordination of meter-dose inhaler actuation and patient inhalation is needed. Next, here are some meter dose inhaler. One diagram of meter dose inhaler can be asked. Meter dose inhaler, short note of the meter dose inhaler can be asked in the GT examination. So this diagram, the left hand side you have to do, which includes all that parts of the meter dose inhaler. Now there are some marketed pharmaceutical aerosol products. The drug like fluticasone and thimerosal, mostly used for the asthma. Flunisolide, becomethasone and albuterol used in the aerosol dosage form. Now comes the formulation of aerosol. It consists of two essential components: product concentrate and propellant. Product concentrate include active ingredient or mixture of active ingredients and other necessary agents like solvent, antioxidant and surfactant. And the another one is propellant. Either single or blend of various propellant is used. Why we need to use the various blend of propellant here? Because single is to exert to expel out the product from the propellant, we need the specific pressure. So that specific pressure, if we are not going to get with the single propellant, we have to use the blend of propellant. Blend of solvent is used to achieve a desired solubility characteristics of the drug. Various surfactants are mixed to give the proper HLB value for the emulsion system. The propellant are selected to give the desired vapor pressure, solubility and particle size. Pharmaceutical aerosol must be dispensed as a fine mist, wet spray, quick breaking form, stable form, semi-solid form. In the form also we have two parts. One is quick breaking and another one is a stable form. Types of system depends on the physical, chemical, pharmacological property of the drug and site of application. Now various types of systems. Types of aerosol system: solution-based, water-based system, suspension or dispersion system, foam system, which is include aqueous stable form, non-aqueous stable form, quick breaking and thermal form, and intranasal aerosol. Solution system. This system is also referred to as a two-phase system, consists of vapor and liquid phase. The active ingredient is soluble in the propellant and no other solvent is required. Vapor pressure of the system is reduced by addition of the less volatile solvents such as ethanol, acetone, glycerin and etc. This results in the production of a large particle upon spraying. Amount of propellant may vary from 5% to 95%. And here is the example of the formula. The active ingredient we need 10 to 15 and the rest is the propellant. Here are the various formulas for the aerosol: inhalation aerosol and topical aerosol. Depending on the water content, the final product may be solution or a three-phase system. Solution aerosol produce a fine to coarse spray. Hydrocarbon propellant A70 reduce the dry particle, while propellant E17 and A31 tend to produce a wet spray. These are useful for the topical preparation and packaged in the plastic coated glass container. Water-based system. The large amount of water can be used to replace all or part of non-aqueous solvents used in aerosol. Products produce spray or foam. To produce spray, the formulation must consist of the dispersion of active ingredient or other solvent in an emulsion system in which the propellant is in the external phase. Since the propellant and water are not miscible, a three-phase aerosol forms. One form is propellant, another is water, and third one is vapor phase. Ethanol can be used as a co-solvent to solubilize the propellant in water. It also reduces the surface tension, aiding in the production of small particles. 0.5 to 2% surfactant is used to produce a homogeneous dispersion. Surfactant with the low water solubility and high solubility in non-polar solvent will be most useful. Long chain fatty acids and all. Propellant concentration varies from 25 to 60%. Aqueous system dispensing fine mist and spray of active ingredient dissolved in water. No chilling effect since only active ingredient and water are dispersed. Propellant is in the vapor state. Difference between AEROSOL system and three-phase system is AEROSOL dispenses fairly dry spray with the very small particles, non-inflammable of the product. Suspension system. It involves the dispersion of active ingredient in the propellant or mixture of propellant. To decrease the rate of settling of dispersed particles, effective suspending agent are used, primarily used for inhalation aerosol. Here are the example of that with the weight required. Physical stability of dispersed system depends on the rate of agglomeration of the suspense solid. Obviously, the agglomeration is accelerated at elevated temperature and it is also affected by particle size of the drug. Agglomeration results in pile clotting, inaccuracy of dose, and depending on the nature of the ingredient, it may cause damage to the inner and metal container. Isopropyl myristate and mineral oil are used to reduce agglomeration. Surfactant of HCl value less than 10 are utilized for the aerosol dispersion. Surfactants are effective in the concentration of 0.01 to 1%. Foam system. Emulsion or foam system aerosol consists of active ingredient, aqueous or non-aqueous vehicles. Surfactant, propellant are dispersed as a stable or quick breaking form depending on the nature of the ingredient and the formulation. Here is the formulation of the foam system, aqueous stable foam. Total propellant content is usually 3 to 5% or 8 to 10%. The amount of propellant increase stiffer and drier foam is produced. Lower propellant concentration yield wettable foam and hydrocarbon in complex case propellant are used. Here is the formula for non-aqueous stable foam. Quick breaking foam. Propellant is in the external phase here. When dispersed, the product is emitted as a foam which then collapses into the liquid. Here is the formula for the non-aqueous quick breaking foam, specifically used for tropical medicament. Surfactant should be soluble in both alcohol and water and can be non-ionic, cationic or anionic type. Thermal foam used to produce the warm foam for saving, used to dispense hair color and dyes, but were unsuccessful due to the corrosion problem and are expensive and inconvenient to use and lack of effectiveness. Intended to deposit medicament into nasal passage for the local or systemic effect. Intranasal aerosol. But the advantages of intranasal aerosols are deliver the measured dose of the drug, require low dosing compared to the other systemic product, excellent depth of the penetration into nasal passageway, decrease mucosal irritability, maintenance of sterility from dose to dose, and greater flexibility in the product formulation. Now, this is the example of manufacturing of aerosol. Empty can, added product, fit, then we have to feed the valve. Okay, first in the empty can, first we have to add the product, then we have to feed the valve, then add the propellant here, the space, and after that feed the actuator. That's all about the aerosol now.